Good afternoon, I am Dr. Dinabandhu Manna, and here I have discussed about one important question that will come almost in every semester, that is prove that change of entropy for mixing of two ideal gas is greater than 0. Okay. So in my previous lecture, I have proved that delta S equal to NCV ln T2 by T1 plus NR ln T2 by V1. Now here, what you have to prove delta S mixing, okay, greater than 0 for ideal gas. So this is the question. So here, first of all, we can visualize this. What happened? Suppose here is a chamber where the bulb is there. This is A and this is B. Okay. So here is the gas particle. This is also the gas particle. Now you here open the valve. Now what happened? Few gas particles will be moved from here to here, and few particles may be moved from here to here. So here is the mixing. Okay. Here is the mixing. So this is delta SA and this is delta SB. Okay. And delta S mixing equal to delta SA plus delta SB. Okay, A, B are the two different types of gases. Now, here we have to assume that only volume has been changed. Okay? The temperature of the two gases and the pressure of the two gases remains constant. So, what are the two assumptions? One is T, that is temperature, and another is pressure equal to constant. Okay. So this is equal to constant. So what happens if T is constant? Then this term equal to 0. Okay. So only delta S equal to NR ln V2 by V. Okay. Now here we try to accumulate what is SA. Delta SA equal to in A, that is number of mole here in A, okay, and this is R and this is ln, okay. V2 means V final, VA plus VB divided by V, okay. And similarly, delta SB equal to MBR ln VA plus VB divided by V. So this is now when you generate this, so use in this equation. Okay. So delta S mixing equal to delta SA plus delta SB. So put this value in here. Okay. So what happens? This is so this is in AR ln VA plus VB by VA plus NB R ln VA plus VB by VB. Now here we will be and log this. So minus has come, so this is VA and VA plus V. Okay, and this is also minus has come out. This is NBR ln, this is VB by VA plus V. Now, as we can assume also that this is number of mole is proportional to the volume. So here, if this is ratio, we can also rewrite this equation as this is in terms of n. Okay? So this is n plus n minus nbr n nb by n plus n. This. Now the moles of A in the mixture of moles of Na by Nb, that is called mole fraction. Okay, mole fractions means number of moles. Suppose Xa is the mole fraction of A. Yes, so that is defined as number of moles of A divided by total number of moles, that is Na plus Nb. So what happened? So this will be minus Na r ln Xa. Okay, and this is minus nbr ln xb. Now, if you will be, this is r will be common, and you multiply by n. Okay, so suppose at first you common the minus and common the r, and you in this into n. So you will be in n, as it is multiplied by n, you will be divided by n also. Okay? It will be divided by n. So here minus will be common out, so it is plus r. So nb also divided by n. So ln xb. So this is minus n. N is the total number of moles, that is n equal to Na plus n. So here in R, so Na by Nb equal to Xa ln Xa plus Xb ln Xb. This is delta SBC. So you have to prove this is greater than 0. So here two things only happen. Xa is positive term, but it is less than 1 because Xa plus Xb equal to 1. Okay, so Xa definitely less than 1. Suppose Xa is 0.9, then Xb is 0.1, and if this is Xa equal to 0.9, then Xb equal to 0.1. Okay. Now, if this is ln 0.9 and ln 0.1, this is also less than 0. Okay. So this is negative term. So what happened? So this term is negative term and this term is negative term. Okay. So inside this is whole term is negative. Here m is positive term, r is positive term, and multiply here is minus. So what happened? Minus into minus plus. So this is greater than 0. Okay. So delta S is always mixing for two ideal gas greater than 0. So thank you so much for listening, and we will meet you in the next video lecture.